In this video, we're going to start with number 1, ionic bonding practice 3, manganese bonds with chlorine. So we need to figure out the ionic compound, the chemical formula that's going to result when manganese bonds with chlorine. And this is manganese 5. It has the Roman numeral 5. So the first thing we need to do is figure out what is our cation and what is our anion. If you look at the periodic table, this is a rough sketch of it. Manganese is located right around here, and chlorine is located right around here. Here's our separation between metals and nonmetals. So as we can see, chlorine is a nonmetal, and manganese is a metal, which means that chlorine will be our anion, and manganese will be our cation. So now that we have that determined, we can now make our chart. So we are splitting up our cation and our anion. In this case, our cation is manganese 5. Manganese 5. That means Mn has a 5 positive charge. That charge comes right from that Roman numeral. And our anion will be chlorine. According to the periodic table, chlorine has 7 valence electrons, which means it needs to gain 1 more. So chlorine will have a -1 charge. So we're starting with manganese, Mn, and it has a +5 charge, and our anion is chlorine, and chlorine has a -1 charge. So right now, our total charges are +5 and -1. They need to equal up to 0. Every single ionic compound is neutral, which means it has a 0 charge, which means the positive charge and the negative charge need to be equal so that the total charge is 0. So +5 and -1 does not equal 0. Right now it equals +4. +5 minus 1 would be +4. So we obviously have more positive charges than negative charges, which means we need to add more anions. We need to increase our negative charge. So if I do Cl1 minus again, notice this charge changes, and it's now at a -2. I'm a little bit closer to 0. I'm now at a total of -3, but I'm not quite, +3, but I'm not quite at 0. So I still need to add more negative charges. So as you can probably tell from this point, you can probably guess how many chlorines I'm going to need to add. If I need a total +5, that means that this is going to have to be a total -5. Well, how do I get to -5? Since each chlorine has a -1 charge, I will need 5 chlorines. So now I have 1, 2, 3, 4, 5. That would be a -5. +5 minus -5 does equal 0. Yay. So in this case, my chemical formula would be Mn. I only used 1 Mn. That's all I have. Cl, and then I used 1, 2, 3, 4, 5. So Cl5. So this is my chemical formula. Okay, so number 2 says highlight all of the transition metals, then name each of the following compounds. So take a minute and look at all 6 of those compounds and just highlight all of your transition metals. Remember, if we're looking at my very rough periodic table, transition metals, or our multivalent metals, are right around here. So in this case, not these, in this case, iron is located right about here. So iron is a transition metal, so I'm going to highlight it. Why did I ask you to highlight all the transition metals? If there is a transition metal or a multivalent metal, you are going to use Roman numerals. You must have Roman numerals. Okay, so now we're going to name this. So we start with our metal, iron. And iron is a transition metal, so I can't just write iron nitride. I need to tell us what is the charge on iron. So this time I'm going to do the same exact thing that I just did, but I'm going to do it backwards. So I'm making my cation and anion chart. And I know that iron is a metal, so that's going to be my cation. And nitrogen is going to be my anion. So I know, nitrogen being right over here, I know that nitrogen has a 3- charge. And I only have one nitrogen. It doesn't say 2 down here, it doesn't say 3 down here. I only have one nitrogen, which means that my total negative charge is -3. I know that my overall charge has to be 0. All of these compounds need to be neutral. So what has to go here? Something -3 equals 0. Well, that has to be a +3. +3 minus 3 equals 0, which means, and I only have one iron, there's no number down there, so that means that iron would have to have a +3 charge. So my name for this compound is going to be iron, Roman number 3, because it's got a 3 charge, and then nitride. Don't forget to change the ending of the non-metal to IDE. Go ahead and try and complete the other ones from number 1 and 2.